Good morning, everyone. First of all, I want to apologize for the webinar this morning. I'm not sure what happened there, but anyway, I was seeing PowerPoint and thought everything was okay, but anyway, apparently y'all couldn't see it. So again, I apologize for that. But this morning's session was on SolidWorks plastics. I am Wayne Matus, application engineer with Progression. Contact information is wayne@progressiontech.com, and I'm extension 295. Okay, so again, this morning session is about SolidWorks plastics. You've built this nice, pretty model, nice and shiny, everything looks good, but there's still a lot of questions to ask. First of all, is it manufacturable? Can you actually mold this part? Is it going to fill properly? Where's the best location to put the gate where you're going to inject the plastic into the part? You're going to have any issues with weld lines and air traps. How many times you're going to have to make revisions to the mold because of model changes due to the part not filling properly the first time. And the cost of all these changes. You're going to have to rework the mold, or you have to start all over from scratch on the mold. It can be pretty costly. And then also the customer. You put this part, this smoke alarm, on the shelf at Home Depot. People can see it through the packaging. Are they going to buy it? Does it look good? Or are they going to reject it and not purchase it because there's some visual imperfections in the part? How about quality? Is the part going to break due to the problems in the molding process? It's not as strong as you'd expect it to be. And also, can I innovate? Can I make it better? This is the SolidWorks plastics product matrix. There are 3 different products in the mixture. There is the SolidWorks plastic standard, there's professional, and then premium, kind of like a good, better, and best. All the products are integrated into SolidWorks, so they're embedded into SolidWorks. So you got the one user interface to work with. So if you know how to use SolidWorks, you can run plastics. There's a material database that comes with it, 4,000 parts or 4,000 materials, plastic materials in the database. You can customize this material list so that you only see the ones you're using. With any simulation product, you have meshing. SolidWorks Plastics has an automatic meshing capability, kind of like an easy button, where it'll automatically mesh your part for you. The types of mesh that we can create, we can mesh shells, and solids. We also have refinement to get accurate results. You can typically refine the mesh in the areas you need it, and we have that capability. There are different stages or phases in the molding process, injection molding process. The standard plastic will do only the filling phase, or the first stage of injecting. The other 2 products, the higher end products, can do the packing phase also. We have the ability to automatically locate gates for you, or you can select your own locations for the gates. We have an instantaneous fill time plot, so as it's solving, you can see how the model, how your part is filling. We have runner balancing in the higher end products when you're doing the family molds, multi-cavity molds. Do shrink mark analysis with all the products. And in the 2 higher end products, we have symmetry analysis now, where you can build your model, half your model, and solve it and get accurate results with a quicker solve time. In the higher end products, we have the mold geometry support, where we can actually include the mold in the model, or we can include the runners. In the highest end product, we can include the cooling lines in the mold. Some of the other advanced features that are capable, and I'm not going to bother reading these. This PowerPoint is actually available on the SolidWorks website if you want more information about it or have time to read it. The cooling line analysis, again, that's in the highest end product. We can do warpage analysis in the premium. Results, these are just a partial listing, but we can export out to e-drawings now. We can do the fill time, how long it'll take to fill the part, ease of fill. It'll tell you what areas of the model are really easy to fill, what having issues with, and what will not fill. A nice product for beginners like me. We have a result advisor, so we got a wizard to step you through the process, and then we got a result advisor to tell you information on how to improve problem areas. A nice tool for beginners like me. It'll tell us the pressure at the end of the fill. It can show us air traps, or we're going to have potential air trap problems and the well line problems. With the highest end product, the premium, we can do residual stress. So there's information, and again, this PowerPoint is available on the SolidWorks website if you're interested in it. So the process of doing a plastic simulation. First of all, you get into your window into the mold. The window into the mold is where you turn on your add-in, and then you set up your study. You can do what-if scenarios in the process. So you try one model, then you can make a few changes, change the size, thicknesses, shapes, injection locations, materials, and you can do all these what-if scenarios until you get the best, the optimal part. And then once you get that optimal part, then you can take it into the family of molds to where you got where you want to make maybe the top and bottom of this at the same time, and maybe even make multiple pieces at one time. We can do the entire injection cycle, the filling, the packing, and the warp. You can then bring it into the advanced tools, and then basically repeat this cycle over and over again for different parts. So for the demo today, I'm going to show you this smoke alarm. So here's the smoke alarm, made up of cover and then the base, and those are made out of plastic parts. So I'm going to start with the cover, and I'm just going to open it up in its own window. And if I go to tools, add-ins, at the bottom of my list I've got SolidWorks plastics. So I've got that turned on. When I turn it on, it gives us a tab on the command manager for our plastics tools, and it also adds a button in our command manager or property manager. The plastics will work in configurations, so you can have multiple configurations for different scenarios. So I'm going to start out with this thick scenario here, where I've got a pretty thick part here. And I'm going to switch to the plastics manager tab, and here's where I could assign the mesh to it, whether it's a solid or shells, and then set up the problem. But for beginners like me, I'm going to use the Getting Started wizard to set up the process. And it's wizard based, and it'll step us through the process. I'm going to go to my next. So the first thing I need to do is mesh it. I'm going to mesh it with shell elements. I'm not going to use warpage, so I'll just go ahead and go to next. And while it's processing, just talk a little bit about the meshing. Shells, solid shells are good for thin wall parts, give us fast, accurate results. If you got thick parts, then you probably want to mesh it with solids. They'll give you more accurate results for the thicker walls. Of course, even thin walls, the solid will give you accurate results, but it'll take longer to solve. So now I've got my body. So I want to mesh this body. So I'll select it and go to next. I can define the triangle size. Basically, this is the size of the element. Now I'll just set it to 10. And this is where I can set up the refinement. Excuse me. I'm going to set it to automatic, and I'll take my slider bar and move it all the way to 5. So this will give us the better mesh refinement. And hit my mesh button. And I got a preview of the mesh. I like it. Looks good. I can hit my next button. This gives me summary information. Summary information is good. I got a waterproof or watertight model. I've got a few bad elements, but not too bad. Now here I can go in and change the mesh, but everything looks good, so I'll just accept it. And now go back to my wizard, start wizard. So I've got my mesh. You can go to my next button. This is where I define the material. Default material right now is the ABS. I don't want to use ABS for this. I'm going to change the material. And here's our access to the material database. Here's my user-defined database, which is scaled down. Here's my default database, which has all the 4,000 plus materials in it. And I got nice visual information here as far as the material properties. I want to make this out of a polycarbonate. I'll make it out of this generic polycarbonate. And there's the material properties for this. The melting temperature, we want to, is between 350 and 250 C. So I want to OK this. And now I'll just go to my next. And now it's read this information from the database about the process parameters. Excuse me again. If I want to change my filling parameters, I could change it. I'll just leave it the same. And go to my next. Now is where I need to tell it where my injectors are located. So I want to add an injector location. If I wanted to add an injector automatically, I could click this button here, or this is a drop down list, and I pick which injector location I want to use, and there's one it found. I don't want to use that one, so I'll just select it and delete it. And I want to pick kind of in the middle of this face right here, and that's where I want my injector. And accept that. And you can see my tree is filling up with information. I'm going to go back to my getting started wizard. So I've got my injector. And go to the next. And the next step in the process is run simulation. So I'm going to run it, bring up my analysis manager. This analysis manager has a suspend button on here, so I can watch how this part is filling. If I don't like it, I can stop it. It also tells me the injection pressure at that point in time. Again, I can suspend the analysis and restart it, make some changes and restart it. So now I'm seeing how it's actually processing along, how it's filling. And I can now see that, hey, I've got a little, where this thicker wall part is filling a little bit faster than these ribs. So I'm going to have some weld lines in these areas right here because it's actually filling from both directions. So I know I'm going to have some potential problems in here, so I could stop it or suspend it and fix the problem. But I'm going to go ahead and finish the run, let it complete, and we'll look at the results that are available to you. And it's getting close to being finished. And when it does finish, it brings up this results advisor. This is where I was mentioning that it has it's a nice tool for beginners like me. So right now I'm looking at the fill time, information about the fill time, when it's displaying, how I can change it. I could move the injector locations. So again, a nice tool for us. So there's the fill time. The fill time is 2.7 seconds. Pressure at the end of the fill is look like 30 something megapascals. Also, any one of the or the fill time, I can animate it, see how it's filling. Just like in the preview. Here's the button where I can actually save to eDrawings the results. So there's pressure again. Let's look at volumetric shrinkage. So there's the volumetric shrinkage at the end of the fill time, 13%. Cooling time, so it'll take almost 50 seconds for this model or part to cool in the mold. So that's a pretty low cycle time. So it's got to cool before we can pull it out of the mold. There's sink marks. Sink marks in millimeters. That's basically the depth of the sink mark. Ease of fill. This is all green, so it's going to be easy to fill. Again, I could look at the result advisor to tell me more information about that. Can either close it from the X button here or from the button here, toggle off the advisor. Also, we mentioned about weld lines. So I'm looking at weld lines now, and you can see these ribs. It's got quite a few weld lines in there. Those ribs are thin with the weld lines. They're probably going to break. Definitely not going to look good. Here's where I can look at my air traps. Air traps are where pockets of air are going to collect in there. The mold is not going to fill. We could even have some burning, a dieseling effect, where the gases from the plastic are compressed into that small pocket, and you could have a dieseling effect where it will ignite. So, and I'm going to go ahead and close my wizard. So know now that this part right here is not very good. So let's go to another configuration. This configuration is a real thin part. I'm going to load my results for this one. I've already run it to save time. And now let's animate this. And you can see here where I got a short shot where the mold is not filling up because it's just too thin to flow the plastic all the way to the other side. pressure at the end. Pressure's 100 megapascals. And let's go back to the fill time and let's look at our ease of fill. Ease of fill, of course, the red is where we got real major problems, where we got the short shot. Yellow is where we're starting to have some issues. So anyway, we can quickly see that this is not good. So we're going in the wrong direction of making this part thin up here at the top. Go to my next configuration. Next configuration is kind of halfway in between the thick and the thin. And let's look at the results for this one. Let's go ahead and animate the fill. The fill still got the weld line problem. But it is fitting kind of decently. Pressure 43 megapascals. Cooling time 27 seconds. So this is in pretty good shape. But we still have the weld lines. Air traps. Still got quite a few air traps, but we can correct those. So let's go to the next configuration. Next configuration, we are moving the gate or the injector location from over here to kind of this corner here. And now you can see from the fill animation, we should have eliminated the weld lines in the ribs. And just to check that, there's our weld lines. Look like we do have a little bit of a problem on some of these ribs, but much better. Air traps, look like air traps are a lot better too. Pressure at the end of the fill is pretty high. Cooling time 26 seconds, pretty good. Ease of fill, it's all green, so it's good. And this is out of that same material. So far all of these materials have been out of the same polycarbonate. All we've done is modify the thicknesses, and then that last change was the gate location. This next configuration, next scenario, is where we're actually changing the material here. So after I load my results, this is out of an ABS material. This material has a little bit different material properties. So the fill time is a little bit less, I think, than it was before. Pressure at the end of the fill is less than it was with the other material. Weld lines should be basically the same as they were before. Air traps should be basically the same as they were before. Ease of fill, still easy to fill. So this model, everything looks good. This is our best scenario for making this cover. So the next stage in the process is looking at a family mold. We want to make, got 4 cavities here, 2 tops and 2 bottoms. And we want to make these at the same time because we're injecting the same material into them. So they'll have the same material properties. And we can make them a lot faster when we do 4 at a time. But the issue here is that our runner system is not optimized. If you look, you can see where the covers are filling faster than the bases. So we really need to balance these so they fill about the same time. I'm going to go to my next configuration, layout 2, and let's load our results. And here you can see where we've modified the runner system to where to the bases we got bigger diameters, so the material is going to flow better, faster. And if I animate this, should be able to see where they both feel right at the same time. Our field pressures 105 megapascals. And cooling time is 21, so we can make a lot of parts in a short amount of time here. I did forget to show you one thing here. I'm going to go back to the to this part here, or this configuration. This is our best configuration for the individual cover. Load the results. And this one we actually used either the plastics professional or premium because we have the ability. We did a pack analysis on this thing too. If I look at my volumetric shrinkage at the end of the fill, it's 11%. Now if I look at it at the end of the packing process, the shrinkage is 3% or a little over 3%. So we can predict how much shrinkage we have, so that way we know how much to scale our part when we start building our mold. So that's SolidWorks plastics. I'm going to switch back to the PowerPoint and kind of do a quick summary on here. So you can see with the SolidWorks plastics we can streamline the communication between the mold manufacturer and yourself. Mold manufacturer could be an outside source or it could be internal. But anyway, it'll reduce the amount of interaction between the two in the communication. Try this, no, that's not going to work. Try this, no, that's not going to work. You can do all that yourself before you give it to your mold manufacturer. That's also going to eliminate costly mold rework. So basically, when you get the part to them the first time, and it's going to be a good moldable part. Now, since you do get that model to them or the part to them right the first time, it's going to decrease the time to market. You're going to have to build multiple molds and try different things in the mold shop. You can try in SolidWorks plastic. It's also going to improve your quality. You're going to get better parts. I want to thank you for attending.